All right, I'm going to go quickly run through announcements and then get to the get toward the guest speakers quickly. All right, I actually need to do it for my laptop, don't I? Okay. All right, so in case this is your first time here, hello, this is GreyHat. We are GT Cybersecurity Club. If you haven't already, please join our Discord over here. It's where we primarily post our announcements and updates. We also have an Instagram where we post like photos and other social details for events that we run. Anyone need these links? We're on Discord. We meet every Tuesday and Thursday from 6:30 to 7:30 p.m. Tuesdays are our CTF training meetings, which will kind of give you like an applied dive into cybersecurity in preparation for our CTF cybersecurity competitions that we play as a team. Thursdays are our general meetings where we'll do things like give talks on cybersecurity, host events with our sponsors, generally do other security-related events together. It's just generally pretty fun. We'll also hold socials a couple of times a year. Another one of our sponsors, Magnet Forensics, is also currently hiring. I'm figuring that a lot of you guys are here for internships today. If you're interested in vulnerability research positions, go ahead and scan this QR code, and you'll be directed to their portal. I'll give you guys a second for that. Anyone still need the link? All right, moving on. Okay, so we've got a couple of still open roles that we're going to be hiring for at GreyHat. We're going to need more security engineers for the LM CTF Agent project, as we've been talking about for the last couple of weeks. Applications are expected to open within the next week or so, or week or two. In addition, we're gearing up for Rec CTF in about 2 months from today. If you're interested in being a challenge author and contributing a challenge to the CTF instead of playing it, please DM me on Discord. I'm Nightspire. Any questions? Cool. It's more of the same from the last few weeks. Again, student line CTF is still down for some reason. So we're going to be figuring out next week, hopefully, whether we're going to be still playing in it. If not, there should be some other CTFs that weekend that we'll be able to do. Outside that, we also have DICE CTF calls coming up about a month from now. It should be pretty fun, both of the events. Questions about upcoming CTFs? Yeah, and again, if you come play with us for a CTF, you'll be able to, if you solve a challenge, fill out a form, or solve a challenge and complete a rap for it. You'll be able to fill out a form to become a competition team member, for which we'll feature you on our website, including your write-up. Oh, message in the chat. The way that we typically do is that we'll play the entire CTF as a group, and after the CTF is over, if it's a qualifier event, we'll usually like post like who's working and contributing towards what challenge, like how much were they working on it, to what extent were they actually contributing, and from those data points, if you will, we'll usually put together a final team, and we'll usually have like pretty good consensus on who we are sending. We also try to prioritize sending new people to events. So unless there's like a very outsized contribution or we really need a specific person to go to an event again after we've sent them to a finals previously, we'll usually try prioritizing newer people. Earlier last semester, we went to New York for DICE CTF finals. Sorry, not DICE CTF finals, for Seesaw CTF finals. This last summer, we sent another team for DICE CTF finals last year. Hopefully, if we qualify again, we'll be going to DICE CTF finals in New York again for later in this semester. Anyone need, well, I'm assuming like this is mostly for people who maybe compete in LA CTF 2 weeks ago and still need that form. Does anyone need that? No? Okay. Cool. And again, our requirements are that you show up to the event, or you don't actually have to show up to the event. You have to compete in the event, complete a challenge, and submit a write-up, and then complete a Google form after the event concludes. Okay, finally, once again, to reiterate, Validin, one of our sponsors, is here today to give a sponsored talk on some of their recent research on Notepad supply chain attack. Validin, and I think also Curtis from Invictus IR, not sure where he ran off to. Oh, sorry. Okay, I missed you. Okay. They're also actively hiring for summer 2026 interns. So if you're interested in an internship, they'll talk about it during the meeting today, presumably, but you can also feel free to chat with them after the meeting's over to learn more about the position. With that, I'll let you guys take it away. You guys be able to screen share from your device?
Perfect. You want to get set up? Yeah. Sharing is not turned on.
Okay. Yeah, it should be sending your request.
Thank you. One more chat message here. So. Oh, just kidding. It's...
So,
yeah, good to hear. Do you want to do a mic check?
Yeah, can you all hear me okay? Is the mic showing up? All right.
Chat, can you guys hear us? If you can't hear us, please put a message in there. If not, no worries.
Yeah, if you can't hear this, send us a thumbs up.
All right. Oh, there we go. We got a thumbs up from 5.
Wait, does that mean they can't hear us?
All right. Cool.
All good?
Yeah.
Okay, so I guess I'll start off with a couple of questions. Was anyone here for our last talk in the fall? If you were here, can you raise your hand? Ah, good, good. So we can fast forward some of the what is Validin bit. So we'll still go over it, but we'll move pretty quickly there. How many of you have used Notepad++? A decent number of people. That's cool. Were you aware of this supply chain attack before this meeting? No. Okay, cool. Well, this will be really interesting then. So you may or may not have been affected. We'll start with a little bit of background. So my name is Kenneth Kenyon. I'm Validin's founder. Founded Validin a handful of years ago. I have with me tonight Elliot Rowe. He's an engineer on our team. Shrikar will be joining us soon, but he's stuck in that famous Atlanta traffic right now. So he may show up at some point during the meeting. See here. So oh yeah, we all graduated from Georgia Tech. So we've been where you are, to some degree or another at some point in our lives. So we can appreciate the journey. So what does Validin do? Just real quick. So we make it our objective to track every domain name and every IP address on the internet. And we want to know when they change. We want to know as much as we can about them. And we want to provide that data to people who are conducting cyber threat intelligence research or investigations to help them understand changes that happen in the internet and ideally help them find things that are related to threats that they're tracking. And so when I say we scan the internet, I mean we're looking at DNS, host responses, we're getting registration data, we're tracking certificates from the certificate transparency log. We're also looking at what other people are saying about domain names and IP addresses through reputation lists and popularity lists and the like. And this results in a lot of data. So we're scanning many billions of domain names every single day, tracking many different attributes about those domain names. To give you a sense of the data that we track, you've seen this slide in the fall, but we're just the outbound side of the request side of the request that we're making exceeds 20 terabytes a day on average. We're collecting over 600,000 DNS answers per second. We see billions of certificates every month, just 1.5 billion from the certificate transparency logs. And so it results in just a tremendous amount of activity. So we've built a lot of custom tools on our end to be able to do the collection at that scale and also to be able to store that data and index it and get it back to people very, very quickly. So that whole stack is completely custom on our end in order to handle this type of volume. So Elliot will tell you a little bit about why we do all this and how it's useful. Yeah, absolutely.
Hello, everybody. Can you guys hear me? Okay, nice. So most of you guys were here last time, and I'm assuming you guys have a good understanding of what we do and why it's important. But just as a quick review, we'll go over kind of what a pivot is and when this data can actually be useful when investigating something like a cybercrime. So let's say you are a cyber analyst at Microsoft.com and you have been tasked with investigating a phishing campaign. So there is a malicious website that's being sent out to your employees hosted at totallynormalwebsite.com. And long story short, it's trying to do bad stuff. As a cybersecurity analyst, you are tasked with finding other websites that behave in similar manners and then essentially creating a proactive block list to then protect your company. This is the core of that's too strong of a statement, but this is part of what cyber threat intelligence does. It is a core workflow. Thank you very much, Kenneth. Feel free to butt in, whatever. So a common pivot or a common way to find other websites that might be associated with this bad website is by looking at its IP address. So if you guys are not in the know, every domain name typically can be associated with an IP address. And this IP address represents the machine that this website is actually hosted on. And this is done with through a process called DNS. And basically, it takes a domain name that's human readable to us. So I can read totallynormalwebsite.com, and it gives us a number, e.g. a IP address that can be that a machine can route to. However, the trick here is DNS is a one-way street, meaning that as a cyber threat analyst, I can only go from totallynormalwebsite.com to the IP address itself. If I was interested in every single other website that's also pointing to this IP address, I could not achieve this through simply just using DNS or the public internet infrastructure that is readily available to us. And this is where Validin's data comes in really handy. So as Kenneth mentioned, we are scanning a lot of websites a lot of times every single day. So we actually have the answer to that question of what are the other websites that are pointing to this IP. And through our data, our historical data that we collect, you can ask us an IP address and we can give you associated domain names that also might be malicious. So this kind of shift in looking at internet infrastructure is what's called a pivot in cyber threat intelligence. And that is, there are many ways to basically look the other direction on a bunch of other different data types. Attributes, thank you very much. That's the word I'm looking for. But generally, pivots just help you go from a single known bad indicator, for example, totallynormalwebsite.com, and then go find other bad stuff on the internet. That's the core thing that we're looking to do with our data. Okay, great. So let's actually talk about the thing that we're here to talk about, which is Notepad++. So if you guys are not in the know, Notepad++ is a text editor that is open source and pretty beloved by the developer community, has 20K GitHub stars, and you guys have also used it a lot. I actually have never touched Notepad++, so maybe I am out of the know here. I don't know. But February 2nd, the creator of Notepad++ announced that its infrastructure was hijacked by state-sponsored hackers. And this is really, really interesting. So what happened was not the application itself was compromised, but the update infrastructure, the servers that were hosting the files that were used to then update the Notepad++ application, those servers were compromised, meaning that when you went to run update Notepad++, instead of getting the correct update.exe file that would then update your application, you would get a malicious binary that would then do a bunch of bad stuff on your machine. So interestingly, this was actually reported in the public forums, actually well before the February 2nd announcement. But someone on the Notepad++ forums was like, hey, I ran the auto updater and now I have a very scary thing that's happening on my computer. Great. So what did this file that was malicious actually do? We aren't going to get too in depth about that because we're here to talk about internet infrastructure and the servers that were hosting this file. But this file itself, there are also actually 3 different files that were hosted on different servers throughout the entire campaign that did different things. But generally, the end goal for these files was to call out to a Cobalt Strike beacon. And this is just a piece of software for command and control. So a command and control server is an attacker controlled server that is used to maintain access as well as continue to exploit victims' machines. So the end goal here was longer term control over these victims' machines. But to look at the stuff that we're talking about here, how was the updating infrastructure of Notepad++ actually compromised, and what can we see from our point of view, which is we monitor like everything on the internet. All right. Shrieker, you actually just arrived right in time because I wanted to get to your slides. Okay. Great. So Shrieker, I have to do you want to introduce yourself real quick?
Oh, yeah. Okay.
Thank you.
Sorry I'm late, guys. Hi, I'm Shrikar. For those of you who were here last time we presented, you probably already know me, but I am a founding engineer at Validin. I've been with the team for almost 3 years now. So yeah, that's a little bit about me. And I am also a Georgia Tech grad, though I think we probably reviewed that already. Okay, shared hosting.
Yeah.
Okay, cool. So like the interesting thing I think about the Notepad++ update hack in general was the fact that notepad++.org wasn't the site that was actually compromised. What was compromised was the shared hosting provider that Notepad++ was sitting on. So I think the idea with Notepad with shared hosting in general is notepad++.org, which is their official website, was hosted on Hostinger, which is a hosting provider. And Notepad++ wasn't the only domain that resolved to the IP address where this thing was actually hosted on, right? So if you look at the little diagram we have here, I'm just gonna pop over so you guys can see me. So like when you do DNS resolution on the Notepad++ website, you basically get resolved to this IP address that tons of other domains on the internet also resolve to. And that's like this edge IP right here. And then what the hosting provider will do, a shared hosting provider will basically have some kind of middleware that sits there. And the middleware is going to proxy the traffic to the right places, right? So it'll say, okay, well, you asked for Notepad++, you go here, you asked for this website, so you go here, and then it sends the traffic in the right places. And there's like many different ways to do that, right? Like Cloudflare is a very common shared hosting provider for those of you who are familiar. And what Cloudflare does is they're proxy, right? So they proxy, but you know, there are different ways. Anyways, the TLDRs, there are different ways to do shared hosting. So what happened here is Hostinger's shared hosting or another shared hosting provider that was renting IP space from Hostinger was compromised. And so the middleware was compromised. And when people actually went to request the update or next slide. Oh,
yeah.
Do you want me to do the next slide?
Yeah, no, absolutely.
Okay, cool. So when people did the update, when people asked notepad++.org, give me the update, or you know, people's computers, they would actually, the compromised middleware would actually send them a redirect that they would then visit, that their Notepad++ application would then visit to fetch the update file. And that was the C2 server where the malicious update was actually hosted. So the idea here is, you know, I want to update Notepad++. I make a request via the application. The malicious middleware, or now compromised middleware, the malicious script in the middleware says, okay, well, actually go visit the C2 server and you can go get the update from there. And then that's where the malicious update was hosted. And like, there's a whole element, I think, of geo-targeting. Like not everybody got the malicious update.exe. It was targeted against specific people. And the fact is, like, they compromised the middleware. So they actually could have done this to like lots of other sites despite Notepad++. But the only ones they actually did it to were Notepad++. And the prevailing theory is that it's because Notepad++ like released statements pro-Taiwan. And so they wanted to send a message. And you can imagine who wants to send a message against an organization that, you know, says stuff that's pro-Taiwan. So that's the TLDR. Let me know if I miss anything.
That was great. Thank you so much. Yes. Okay, great. So that is the rundown of what actually happened with the infrastructure, and just a couple of fun notes. In addition to this is only possible because the Notepad++ updater, that piece of software, did not like do any sort of checksum or like verification of the actual file that it was downloading. So, and it also followed redirects. Like, I don't know what they were doing, but I went in. You could literally find the line in GitHub. I should have put it in this presentation, but you could literally find the line in GitHub where they enable following redirects for this updater because it's all open source.
They disable, you mean? Like that's part of the patch, right? Or
No, they still follow redirects, but they now actually verify that the file that they're downloading is coming from the correct place and is what the place is saying it is. So, that's good. But anyways, that was a little bit of a tangent. But yes. Okay, great. So this is what actually happened. And then we saw this go down February 2nd, and there was Notepad++'s public incident report along with Rapid7's public incident report as well. And between those two reports, on February 2nd, they reported this set of indicators to be associated with the infrastructure that we just talked about. So to break these down a little bit, we have the file downloader IP, or one of them, that was reported by Rapid7, and this would be the IP address of this C2 server here, or this. It would function as the server there, and then all of these lovely URLs and IP addresses are Cobalt Strike beacons. So these are a bunch of different URLs and IP addresses that they observe the malware calling out to and trying to get messages to come back to. So this is what we had to work with on February 2nd. And then I'm going to actually hand it over to Kenneth to show you guys how we were able to expand on this set of indicators and find more bad stuff associated with this campaign.
Thank you.
You got a browser up? Yeah. Here you are, and we're in the demo. So I think you have the domain recently. So actually use
Yeah. All right. So it's api.skycloudcenter.com.
Test your memory here,
Wait.
Kenneth.
Sky Cloud Center. Remember Sky. Skycloudcenter.com. Yeah, go ahead. So what we're doing right now is we're going to search the fully qualified domain name api.skycloudcenter.com. And what we do inside of Validin when you do this search is we look across all of our connected sources where we collect data, and we provide them in a single pane of glass. So we'll show you OSINT references. We'll show you a summary of those indicators here. We see that these are associated with this threat group called Lotus Blossom that has a number of aliases, and that's one of the names that this particular threat actor has been given over time. We also show you through the OSINT tab when this domain became known as malicious. And so let's see here. Actually, we see a number of different sites that have reported it. We also see a timeline showing when we first saw this domain name on these various block lists that we're tracking. The interesting thing for us is actually going to be the resolutions tab. There are other views in here, but the resolutions tab is the one that I'll double click on, or single click actually in this case. So in our view here, we've actually been tracking this domain since late August. So August 31st is when we first started tracking and resolving this domain. And what we see here is the IP address that showed up in the Rapid7 report. And so the Rapid7 said, we've observed this domain name pointing to 61.4.102.97. We also noticed that for a few days, if I mouse over it, you can see the actual time. For a little less than 5 days in December, shortly after I guess this was cleaned up. This was cleaned up on the 2nd of December, and shortly after it resolved to a second IP address for a few days, and then resolved to localhost effectively. So what we're going to do is we're going to use the technique the very basic technique, pivoting technique. We're going to click on this IP address, and we will see other things that are connected to this IP address. So we'll have host responses, host connections, but notably we'll have this tab here called host resolutions. And now what we've done is we've looked the other direction. And we've found through our history the other domain names that have resolved to this IP address. And if we go to the timeline view here, we can see something a little revealing about this. So one, the this SkyCloud Center domain, the one that we that was initially reported. You see that complementary view. It's the exact same timeline segment because we're just looking the other direction. But now we're seeing a second domain, api.cloudtrafficservice.com, that a short time after this one stopped resolving to this IP address, began resolving to this IP address. And so this is really interesting because first it has a pretty similar structure, API dot, and then some cloud themed domain name, and then .com. And then second, it was interesting because this domain name continued to point to this IP address for some extended period of time. So we don't know because of our vantage point how this was used. We can see if there were any responses to this IP address. We can see those over here. For the most part, we see there was a response on port 8080 and port 22, but otherwise this IP address hasn't been open on other ports. But this was one of the several techniques that we actually used to find additional infrastructure in our blog. So yeah, any questions about that? All right, great. Well, I won't go into all the techniques. Do you want to switch us back to the slide? Yeah. But if you want to check out our blog, it's you can just go to validin.com/blog. It's one of the most recent blog posts that we have, and you can see some of the other things that we did to identify other infrastructure using similar pivoting techniques. All right. So with that, we would like to invite you, if you're interested, to intern with us. So we are opening up our internship program applications next week. We have you guys get a preview here if you go to this URL, or you just go to validin.com/summer-internship-2026. You'll be redirected to a Google form. This Google form you can use to fill out to express your interest in interning with Validin. And we'll also be at an event next week called Startup Student Connection. Have any of you heard of this event, Startup Student Connection? Okay, very few people have heard of it. So yeah, so we can do you know the link off the top of your head? Can you find it?
I'll find it.
Okay, so we'll find the link for you. If you're interested in interning at a startup, interning or working for a startup in Atlanta, there's an event called Startup Student Connection. It's at Atlanta Tech Village in Buckhead, and there will be, I think, 18 to 20 different startups that are hiring. Most of them for internships over the summer, but they're hiring for mostly technical positions in Atlanta. We also have Curtis with us today from Invictus IR, who is also here. He's gonna be stick around after our talk. So we encourage you to talk to us if you're interested. Meet us and get to know our get to know the team a little bit and see if this is a position you'd be interested in. All right. Well, thank you very much.
Right. Well, thank you so much, Kenneth, and everyone from Validin, and also Curtis for coming out here tonight. The way I probably should this.
Right. Thank you, everyone, for coming out tonight. Thank you also to our guest speakers and to Curtis for making it to the event as well. All right. So I guess for format for the rest of the meeting today, I guess we can field like if you guys have any last minute questions you want to ask regarding Validin's presentation, we can go through those first. But other than that, I'd like to, yes.
Regarding that, we have more examples of interesting fun pivots. If you guys are interested in seeing how we associated the full set of infrastructure, we can quickly go through those. But also, like, we do want to meet you guys and talk one-on-one. So yeah, if there's interest, I see one head nod. I don't know if that translates to other head nods. Okay, cool. Would you want to go through the file downloader IP, the other one?
Yeah, absolutely.
Cool. I'll have to remember what I did because that's the only one I practiced right before the meeting.
Oh yeah.
I don't use a Mac, so
Cool. Yeah, and then the IP is this one.
Which one?
The one in the red. 517.
You put 59. That's 95.
Thank you. What was the last?
I can't remember. Oh, 213.0. It's right there.
That's 0. You've searched for this before. Okay. All right. Do you remember what exactly we did on this one?
Yes, it was a combination of header hash and body hash. So
Okay.
um,
So I guess one of the things we look at when we're pivoting is we pull up the timeline view, and if someone has reported activity and provided dates, that's really great because this is cloud infrastructure. It rotates quite a lot. AES Chupa is also known as Vulture or Constant Company, and you know they rotate IP space. So you don't necessarily know if something is maintained by the same person. You can get little clues from that. So we look at our timeline view and we try to deduce some information about how this thing has behaved over time. So what we're looking at here, these are different sorts of attributes that we've extracted from the way that this IP address has responded when we've tried to talk to it. So if we want to see what those attributes came from, we can actually click around this box here, and we'll open a slide out that shows the different connections to this attribute. So what we can see here is that we made a request to port 80. This is the date, and this was a response banner. And so this attribute here, HTTP 1.1 403 forbidden, this is actually that first line in the HTTP response header, and it's also a very, very popular pivot. So we estimate there are about 6.4 billion connections to this. Now, that doesn't mean 6.4 billion IP addresses or domain names. It actually means that we've observed that connection 6.4 billion times over the last, 100 days?
300.
300 days?
Yeah.
So that being said, that means that you're not going to learn a whole lot by pivoting on this. You're going to get a whole bunch of unrelated websites. We provide these estimates here for that reason. So if we go down to this one, we see 63 million. We see other sorts of hashes is 2.1 million. So we're getting a little bit more specific. And so what we did is we looked at the dates of the reported activity, and we tried to map that to when we thought that this thing was actually active. And so we see activity from August. We see a couple of distinct time periods of activity here. So we see like a little line here that indicates there were a bunch of measurements made where things behaved a very particular way and then did not behave that exact way again the next time we measured it for the duration of this. And we also see a couple other little isolated bits of activity here. So we see a banner hash from early February. We see another banner hash in May. And so what we're inferring here is there was maybe some bit of activity right around this date, and then maybe something changed, and then on September we see another change, and then we see a little bit of prolonged activity starting in October, and then kind of going through December 4th. And again, this was discovered and rooted out on December 2nd. So, that kind of end being right around that first week of December is itself perhaps a little telling. So I would imagine that Vulture, Constant Company, would have had to act if they knew that this activity was happening on their own servers. So if this was a report, they probably would have addressed it. And I imagine that a company doing incident response would probably notify a company like that. But what we're going to look for here is we have ways to filter this data to get things that are what we consider low connectivity. So we're looking for attributes that don't connect to a whole lot of other things. So if we were to double click on those, I use that figuratively. If we were to pivot on those attributes, would we find a lot of other things connected to them or very few other things? Now, typically, when you're trying to find other related infrastructure, you want to find attributes that are rare. So that's one of the reasons we collect so many different attributes, is we're trying to help you find rare attributes or rare combinations of attributes that can help you identify related infrastructure. So we have this ability to select pivot counts that are very low in cardinality. So when we do this, this actually greatly simplifies our view, and we see banner hashes that, if we go back to the table, you can see exactly what it is. So we see these, I guess it's body hashes, banner hashes, e tags, and last modified dates. And what these are, a body hash is just, if we take the full response that we got from the server and we hash it with SHA-1, this would be the hash of that content. And so it's not the headers, it's the actual response that would be used for rendering inside of a browser. Whereas these banner hashes are hashes of this component, this HTTP response. So in this case, if we're pivoting on this banner hash, we would find things that had this exact set of things. Now you said was it this specific header hash? You remember?
There's only two up there, so it's either that one or the other one, probably.
All right. Well, this one's from February. I don't think it was this one. I think was it the body hash? All right. So we're gonna click around on a few things. We're gonna do what's called pivot and find out. So we'll look at things that shared this body hash, and that was so rare that was the only thing. This one had one additional response. It looks like a mail server, probably not related. I want to say it was actually a header hash. Maybe it was this one from October, early October. Actually, that looks right. Okay, that's what it was. Okay, so it was this one. And so what we see, there were 172 records. So 172 in this case, probably not stealthy enough. 172 is a little high. So what I'm going to do is I'm going to pull up this view again, and I'm going to look for the. This is where I actually combine this with the header hash. So this header hash here, we have two ways of hashing our banners. We have a method that involves only hashing the keys of the banner, and then we have a method that involves hashing both the keys and the values of the header, where the key is date and the value would be this, and then also that response line. And these are useful at different times. Sometimes one is going to be really great, and sometimes one is not going to be, really great. It might be too specific. So what I'll do here is I'll actually copy this header hash. There's a simple way to pivot that is available to even people who are using our community version, and this is to apply filters through this view here. Whoops, I accidentally went back. And so in this filter view here, we can take this header hash and apply that filter this way. And then if we hit apply, what we'll do is we'll search for things that had this body response and also had this this header hash. Did I? Oh, I pasted the wrong. Oh, whoops. Okay, pasted the wrong one. Let me go back. All right. So it was this one, and then the header hash was this, right? Mm-hmm. F04. All right. Oh, I see.
I'm a complete gotcha there.
Paste. I guess I know enough about Mac to know how to paste. All right. So when we completed this, what we identified was a second IP address that wasn't in the original report, and then we can look at the timeline of this as well, and we can see like when we're looking for related infrastructure, timing is actually a really important aspect. And so if we suspect something is being stealthy and it's moving around, and then we see a kind of staircase pattern with our searches, we have higher confidence that we're onto something. And so when we see this pattern here, this is usually a good sign. There are two times it could be a good sign. Sometimes if things are stack up and they're all doing something at the same time, that's good. And sometimes if the infrastructure is rotating, that's also good. So in this case, what we did is we applied this header hash and we said, not only did this thing respond with its exact response, but it also was configured on the server level to behave similarly, like it had a similar, type of response from the server. And then, so if we were to get rid of this header hash and just show you what we see in that table without that, we do get it's still a couple hundred, less than 200 connections. But if we look at our timeline, what I'll do is I'll sort by first seen descending. It's my favorite way to sort. First seen descending shows you the things that most recently did this thing for the first time. So first seen descending is a great way to get that view. And so what we see is there are other things in here that kind of show this pattern, this staircase pattern, and you could reveal, in some cases that it's actually, it could be a particular virtual host, or there could be other explanations for it. And one thing that we left open when we wrote our blog was there may be other things that are related that we didn't capture here, that are that we just didn't have enough information to say, yes, this is definitely related to that campaign. So there's actually plenty more here. We've actually seen people at later dates convict other IP addresses on this list. They had their own reasons to suspect that they were related, but we didn't have high enough confidence when we reported to do that. So anyway, so one of the great things, you can go way back in time and you can see that this particular combination, that particular response has been there in some form or fashion quite a lot, and it is fairly unique in that at any given point, not a lot of things have this exact behavior. And just to round that out, if we were to look at the actual HTML content, you can do this in the enterprise platform. We can go back in time. You can see this fairly simple message: service is unavailable. And again, that's a hash of the content. So even if you capitalized or lowercase, an individual character, you would have a completely different hash. And so what we're seeing here is this like seemingly simple message, service is unavailable, was actually enough to be like globally very rare. And we see that a lot, that these tiny little subtle things that introduce some tiny custom aspect to it were enough to give it a tell that through our many different layers of collecting attributes and fingerprinting allow us to find other things that had that same tell. So, all right. Any questions? Yes.
You said you had two different types of hashes, one for just the keys of the headers, one for the keys and values of the headers, right?
Yes.
So there's a header for date with like the exact time of the response. So would there ever be any like overlap between two different responses?
Yeah, so that's a really great question. So the question was, your banner hash captures the keys and the values. Dates typically are going to show you the exact moment that you made the request. And it's going to be different, from second to second. That's a great question. So our banner hash, I kept things a bit too high level when I described it. There are fields that we will blank out for hash calculation purposes. And there are fields that we have determined are effectively globally unique, or unique in some way that is not really particularly relevant from a fingerprinting perspective. And date is one of those. We have expiration time as a consideration as well. Typically, expiration time can be like a fixed amount of time from now into the future. And sometimes that delta is actually what we use, the delta from now to the actual expiration, because that can introduce some fairly unique aspect to the way it responds. So by looking at it, you wouldn't know, but our fingerprint is going to connect you to things that had that exact configuration of expiration start to end. And so other things that we will blank out are like the unique request IDs that you see in Cloudflare, Vercel, and other sorts of servers like that will stamp the request for request logging purposes. So you can debug and you can go look in logs and and that sort of thing. So we will not include those in our calculation. We will show them for completeness, so you see exactly what actually was there, but we won't use them for the hash calculation. So good point. Any other questions? All right, great. How are we doing on time?
Was it
15 minutes.
15 minutes? Okay.
After like our meetings officially over, I'm understanding that for us.
Okay, cool. All right, so we'll wrap up this portion of it, and we will hang around here, and we'd love to talk to you. Thank you.